Are you starting off with your demo straight away, or do you want to?
No, we'll go through an update. It's been a couple weeks. We'll let everybody kind of know where everything's at, what's been going on. We've had a little bit. Uh, I guess we haven't done this for a couple weeks, so I think we got a little catching up to do. And then I think we'll open it up to Q&A afterwards, and then kind of get some people's questions, make sure everything's covered. And then from there, I'll dive into the demo for those that want to see it. All right. So I guess, Paul, if you want to kick it off, you're usually Mr. List. So
My list is actually quite small this week. We've well, actually, let's start by saying that the dev team has been impacted, obviously, by the events of last week and the theft that took place, and that theft was as a result of a hack on our GitHub, which we've now established that was the case. The one piece of information that I wanted to share about this that I don't think we really made clear in the Medium article was how sophisticated the attack was, and the great lengths that the attacker went to try to cover their tracks when accessing our GitHub. As far as to say that they exploited a bug in GitHub, and this is the thing that people don't know yet. They exploited a bug in GitHub that allows you to replace binaries without going through the update release button that you need to press. You can edit a release and view the information, and then change, and that's where you can change your binaries, and then you have to click update release. There's a very big bug in GitHub that Colin and I discovered, where you can edit binaries and delete a binary and replace it without clicking the update release button. And why that is really important, and this is why we know that our attacker was very sophisticated, was that if you click the update release button, it sends out notifications to anybody who subscribed to that release, and we would have known that the binary was changed, and we would have been able to detect it. And that's why we didn't detect it, because they exploited this bug. We've already provided information on that bug to GitHub, although they've been quite quiet in responding to that so far. Like, they basically ignored me, but I'll chase it up with them. But that's the one piece of information that I think that we want to relay, is that whoever did this was actually quite sophisticated. And we may as well explain now that off the back of that, we have been talking to a security auditor or a security company who's going to be helping us with our security processes, as well as auditing our code, and helping us to prevent this kind of thing happening in future. So anyway, all of that, and spending time working with security company and working with GitHub and all of that has impacted our ability to get code done in the last couple of weeks. But we have managed to get through some stuff, and most of that has been on our object registers and validation scripts. You'll explain a bit more about that, Colin, because you're about to demo the stuff that you've been working on. There's been some work done on tritium staking, so staking to sig chains. That's in progress, and will be done, I think, within the next week or two. The API's had a fair bit of work on it as well. We're trying to polish it, adding some features to the APIs just to make it a bit more usable and a bit more secure. The module market is something which is very, very near to completion now, and the guys are integrating that into the main UI code now, and I'm hoping that Dylan's going to be able to, or Dylan Kennel, I'm not sure who yet, will be able to demo some of the module market functionality on the Zoom call next week, give you guys a bit of a preview into what's coming and what they've been working on. And I think that's pretty much it from from the development that's going on, there's been some work done on the Python SDK, just to get that up and working. The Python primer, which is like a test for the Python SDK. That's a really good little tool that I would recommend if people want to join the testnet and run that. It gives you a good insight into how assets and tokens and tokenization of assets works. There's some good output.
Can I say a word about the primer? The primer was originally used as a simple, very quick, just test of all the APIs so people could learn how to code Python to the APIs. Now, with the APIs becoming more advanced, it actually does more than that. The idea is if the community could help, there's also an SDK test that should be evolved to testing lots of combinations of things. If somebody is inclined to want to write test code, it would be very much appreciative.
Yep. And I know Daniel Zan is working on a C# SDK right now. So you guys know the difference between an API and an SDK. An API is an application programming interface, and an SDK is a software development kit. So these SDKs are written in a native language to basically abstract on top of the API and allow you through your native language to make native function calls to access the functionality of the actual API itself. So Dino's been working on the Python one, and then Daniel Zan from Slack, who built Nexplorer, is starting to play around with the C# one. We hope to see a lot more community involvement in development in the actual development of these SDKs, so that it's kind of a one-for-one, pretty easy to port it in any language without having to deal with the HTTP protocol and all of that.
Yeah, on that, Daniel Zan has been helping with the Tritium testnet testing by developing his that C# SDK, which he's going to be using for his own block explorer, but he'll extend it to make it publicly available. On the testnet testing, actually, the legacy network is looking pretty stable, pretty good now. We're happy with that. There's been some work done internally on so this is using the Tritium framework on the legacy blockchain. That's looking pretty good and ready to go, I think. The Tritium testnet, on the other hand, is stable. We've been running that for several weeks now, and the consensus side of things is looking very stable. We're very happy with that. We are noticing some issues with the messaging between nodes, and those issues are coming about because we basically ported the LLP from the legacy server to Tritium server, and we've recognized that really we need to do some work on that message set to get rid of a few errors and basically make it a bit more efficient. So there is going to be some work done over the next week or two on the Tritium LLP, which is going to bring around a bit more testing on the Tritium testnet. And we'll keep you updated on those changes. And I think that's pretty much it. Probably, has anyone got any questions for us before we jump into a demo?
I'll give a little update on the object registers, I think, too. Give a little color on that, so you guys can kind of know what to expect. And also,
Colin, you're a bit quiet to me.
Yes, sorry. I'll give a little update on the object registers, a little more color on that for those that are a little more technically inclined. And then also a little bit of understanding where the wallet is and where that's coming. So the wallet, as far as the core modules, seem to be pretty close to complete. So the only thing that's holding it back there is getting developer certificates for both Apple and Microsoft for the auto updater, which means that the binaries themselves will be signed by a certificate that is assessed and approved through each one of these vendors, which means that you'll know that you're not getting the wrong binary and you won't have any of these issues in the future. And that'll also get rid of some of the flagging issues and downloading the app and then having to click, force open, essentially like you have to do with OS X, which I think will be really good. So that is one of the things that's pending for the actual full wallet to be released, along with the security audit, which we've engaged with independent security evaluators they're pretty well known. I think Adrian is one of the guys you see Integrity Show in Slack. He's one of the guys that's involved with them, Nathan, who what they're basically doing is they're starting an audit of, number one, our security processes, and the staging branch, which is the Tritium beta, which runs the actual Tritium node, or that's the Tau framework overlaid over the legacy rule set. And then the wallet itself too, so that we can make sure that that's ready to ship. And it's had a very thorough audit before it does ship. So that's going to be the first thing that's coming out. And then onto the object registers a little bit. The cool thing about them is, think of them as like little objects that you can actually create. So they have little schemas, and you can actually create data fields in them, and then assign certain fields to be editable or modifiable, and then create kind of a notation, whether it's through JSON or XML for a schema, to define these objects. And these objects themselves will essentially be self-contained, and they'll have their own validation scripts within them. So that's where we get a lot of really, really fun behavior, such as I can create an object that represents my asset where only the description can change, or things such as that. So that's that code's actually fully complete, and it's working in the validation scripts. I can show you guys some of the benchmarks too when we do some of the demonstrations to show you the performance of the actual register virtual machine versus the actual object registers. And then that's just being woven into the actual main network now, which essentially an account is going to be an object register that's defined by having a balance and an identifier, which the identifier is the token. And then there's kind of different polymorphic behavior that happens with those. So just think of it as kind of like a bunch of pieces of Legos that anybody can really design and say, well, I'm going to design my asset and define as metadata. And that metadata itself is enforced through the network so that certain fields can be modifiable and certain ones can't. So that was a pretty big step along with validation scripts in order to be getting the full functionality, which the validation scripts, so you know, are kind of the foundation of the DEX, the decentralized exchange. They operate on a 64-bit register virtual machine, where Ethereum is a 256-bit register virtual machine. Now, more bits doesn't always mean better. It actually sometimes, in this case, means worse. In the case of Ethereum, they're using 256 bits, which means there's 32 bytes that are required for any account balance. Now, your account balance is really not ever going to be over 1 billion or 5 billion tokens, right? So you really only need about 4 bytes. But they have 32 that's needed for every one of them, which is one of the reasons their blockchain is really overbloated. And another part of that makes it slower too is when you have a really big number like that, the native the native CPU cannot process all of those segments of data at the same time. So it has to work through them in 4 or 8 byte segments, which makes the computation even slower. So I've seen certain implementations of the Ethereum virtual machine, the JIT-like one, and I think their average instruction time is about 1 million to 1.2 million nanoseconds per instruction, which is pretty slow. But virtual machines themselves are. Our register virtual machine is anywhere from 30 to 50 nanoseconds. So it's an extremely fast virtual machine, which means that's kind of one of the other steps, because when you're building a software stack, you're always limited by your tightest bottlenecks. So if you have a bottleneck in any place, or if you can manage to remove any bottleneck, you're always going to get higher degrees of scalability. So that's going to really help in our actual smart contract processing, and having a higher, or a lower time per instruction in its actual processing allows you to have more complex contracts that will still process very quickly. So it's looking really, really good. A lot of that's statically tested. And then the validation scripts can actually access object registers in the global scope. So you can actually make certain Boolean representations, which means like true or false space. Hey, this account has this token identifier of Nexus, and I want to make sure that it has a balance of 100 before I allow mine to go. So you create these links of conditions on these object registers and the operations and the validation scripts that allow you to program that functionality. Now, for you as a user, you're going to basically be able to just say, I want to create the savings account and I want to make my spending limit this. And, you set those parameters yourself. So it'll be easier from the user experience, but for the developer, especially the one that gets down in the API, they'll be able to start to build out a lot more of this really cool contract functionality. So that's been a really cool step to see that kind of evolve and come together. So we've been really excited about that, or at least me. Everybody's been hearing about it, but like the object registration. So this is kind of a bit of a quick update on kind of our side of things and where we're at. We're looking pretty good. So our internal goal is to be feature complete by the end of the month and be in a lot of extensive testing through May, which includes security audits and, more public test nets, and then hopefully a little bit more interface functionality in that. So that's kind of a tentative time, but we're holding ourselves internally to that so that you guys kind of have a little window into exactly what our internal processes are and what we're holding ourselves to as far as our internal deadlines. And I think that pretty much covers just about all of it. I just wanted to give you guys a little bit of color on that before the demonstration. And then one last thing too is recovery for signature chains. So there is the issue of what if you forget your password or what if your signature chain is hacked? And that's a potential problem. So what we've actually been developing into the signature chains now is a master seed phrase or a recovery phrase, kind of like 20 words or 100 words like you're used to if you use hyperdeterministic wallets for Bitcoin. But this will be something that you keep safe where you can hand 5 words to, a spouse and 5 words to your mother or something else. If you want to scatter that around or keep it safe in a vault, but that will allow you to change your password at any time, regardless if you know your password or not, as long as you know that master seed phrase. And that seed phrase will have a lot of entropy, which means 20 words is generally about 128 bits of entropy, which think of that as a really, really big number. And then obviously the signature chain, or in order to generate that key or that hash, it's going to require a pretty intensive Argon 2 hash, probably 30 to 60 seconds. So you can be guaranteed that it would be ridiculously difficult for anybody to be able to even hack that. So that would be a way. In light of some of these things we've seen with GitHub and everything, I thought, well, we should probably put another security measure in there just in case you do forget your password, or just in case somebody does hack your sig chain, which right now we've told you with the Argon 2 hash being 500 milliseconds with an 8-character password, even if your username and your PIN number were known by the attacker, would take on the order of about 3 to 5 million years in order to actually break into your sig chain. So it's already extremely secure as it is using that password hashing algorithm. But this master seed phrase is something that you can have as an extra assurance, essentially, that that you can always recover your sig chain in a worst case circumstance. So then one last thing, while we're at it, this is something, I guess, I've kind of thrown this idea around, but I think in regards to this hack thing, I think the biggest problem of this hack thing that happened is the centralization of GitHub. So kind of food for thought for some of you guys. And if some of you guys are developers and you're kind of inspired by it, I've been kind of toying around with the idea, throwing around with Keith and some other people about a decentralized GitHub and having kind of a hybrid network that operates on its own proof of stake token that uses Nexus to secure itself, that we can modify the actual Git open source code where you can push and pull code directly into this repository and essentially have your code hosted on the blockchain itself, which is, I think, a truly decentralized way. A decentralized system is only as decentralized as its most centralized point, and GitHub in itself is a central point of failure for every single cryptocurrency. So I guess in a silver lining of this whole thing, it's been good to kind of to analyze the situation too and realize, okay, well, I think the biggest folly of this specific situation was the centralization of GitHub, which is now owned by Microsoft as well. And a lot of cryptocurrencies, including Bitcoin Core, are essentially known to be only on GitHub, as far as that's what people think Bitcoin is github.com/Bitcoin/Bitcoin. And I think we need to change that. It's a longer term idea. So if any developers are kind of interested in this idea, I think it would be a really great use case for object registers. And then the organizations themselves could actually become DAOs so that the SIG chains can vote, and then developers can publish binaries from their SIG chain specifically as well. So just kind of a little idea, food for thought, if any of you guys find it interesting. But that's kind of another thing that we've been toying around with in light of this whole thing, because that I think that's something that's going to become more and more necessary as we see this industry evolve. So, all right, that's all I got.
I've got a couple of questions that have come in, both from Kane, actually. First one, are you planning to write an article on the architecture of the VM and validation scripts and how all that hangs together? So just something that we've got out there that can explain how it works to people.
Yeah, we want to get more articles and consistent content out. Right now, a lot of our writing is concentrated mainly on getting the website content finished and getting the website out the door. But yeah, that's definitely something we'll want to do on kind of explaining some of these differences and our choices in architecture, and why that kind of shows that it's kind of a more efficient architecture to be operating on, and why we've made some of our design choices. I mean, as far as I'm aware, most every cryptocurrency that uses smart contracts, quote unquote, is either based off of the Bitcoin script engine or the Ethereum virtual machine, which means that you're going to inherit the negative qualities of both. And I haven't, to my knowledge, seen anybody at least do what we've done. So I think elucidating and explaining the significance of that, I think, will be really good for public awareness, definitely.
Yep. The second question is, what features of the APIs, tokens, accounts, etc., are planned to be integrated into the wallet UI?
So that's still kind of tentative, but as far as it's challenging to think about how you integrate all of these things. So we'll probably see, since the wallet's modular, we're creating the module market or the app store, or the dApp store, or whatever we decide to call it. So these apps will probably be a little bit more segregated, where you have assets, and then you'll have your tokens, and then there'll obviously probably be a DEX app, which will allow you to be trading some of these and managing your different accounts. Then there's probably going to be the Nexus specific, where you can check your Nexus, and then, maybe, I don't know, other extensions. I think there's a lot that's going to be there. So I'm not entirely certain on exactly how that's all going to be converted into the user interface. Not all of the user interface accessibility is going to be integrated directly into the wallet. There's going to be other application developers, like some of the things that Dino's been creating, that have their own web interface and anything as well. So I think there's going to be some domain specific applications, and then there's going to be kind of the blanket, how should I say, generic applications that we provide. And then obviously any other developers that say, oh, hey, here's my new version of the asset exchange or the decentralized exchange module, or, things like that, they'll be able to obviously build them and open source the code, and then you'll be able to download those modules themselves. So we hope to see a really colorful ecosystem as far as what modules you're going to have access to, and variants in the user interface for, things that are more applicable to people's desires.
Yeah, as you say, these things can be added over time by us, but more importantly, they can be added over time by other developers through the module market, and that's what's quite key and cool about the module market. But I think, yeah, the basic functionality of being able to view your Nexus account, and which is a token, just the same as any other tokens that you can create on our framework. Be able to view your balance and send and receive those. That's kind of basic functionality that needs to be in fairly soon. And then the rest of the things, like being able to create tokens, create your own token and create accounts for that token and send and receive those, and that can all come later. And I kind of see those being in a separate module, not integrated natively into our UI.
Well, each application will probably have their own tokens, since tokens form utilities, other applications that people download. This could be the one that has CryptoKitty tokens, and they have their CryptoKitty object registers that you can transfer between each other, and then a native token that you can exchange on the decentralized exchange for the asset to the token, and buy these CryptoKitties and stuff. I see they're probably going to be a pretty specific. I mean, just creating. I mean, how should I say it? You can create a token and an object register for just about anything. So I think the applications of it, I think, are beyond what we can truly see right now. I think there's going to be a lot more as we start seeing more development coming, and a stronger development community building around that. I think a lot of people's ideas are going to completely be things that we didn't even think of at this current time.
Yep. I'm just checking to see if there's any other questions, but I can't see anyone. No, I think we're good. All right. Do you want to jump into your demo?
I guess so. Any questions before we start the demonstration? No? Okay. All right, I guess I will start sharing my screen. All right. Now you guys should see that. Okay. You guys can see the screen? Everybody good? Yes. Yep. Okay. So I didn't completely set this one up because I figured I'd show you guys a little bit more of what's going on here. So what I set up basically here is a couple accounts. So we have username drummer. We have a username singer over here. And then we have a username label over here, and then we have a username fan over here. So this is going to show a basic kind of music application and how it would work. As you can see right here, I did set up a native currency. This is my token identifier 1. It's got 1 million max supply. So this number 1 here is on the next demonstration. Most likely you're not going to see this number. It's going to be a ticker. So just think of that number as the unique ticker for that specific token. Identifier 0 is obviously Nexus, but in this specific instance, I'm not using Nexus. I'm just showing that any token can be used for any split revenue payment. So let me see. All right, let me just get my head around it. This setup is a little bit more challenging because there's a lot going into it. So right here, I guess I shall show this is a node running in private mode, and then this is obviously the node, or I should say the other one that I had to overlay. I would show this in the background normally, but I figured for the sake of this, I needed to actually have another account rather than switching away. So the role of this guy right here is the fan. He's going to be buying some music for somebody. The role of this guy over here is the actual label or the administrator, which is creating the token that represents your rights, and they're called shares in this case. I think I named this one Greatest Hits Shares. So this token itself right here was actually created with a supply, I believe, of 100. So if we go right here, token/get, type equals token, and name equals Greatest Hits Shares. This will load up the actual token. This one's identifier 3. So what this token over here represents is your actual ownership of some sort of work of art. Let's call it an album or a song. So now over here, this guy created an account. I need to move this thing. Can I minimize this? Hide thumbnail. Thank you. Great. Okay. So this right here, I created my initial account for the drummer shares. So if we go token/get, type equals account, name equals drummer shares. This should show an account of identifier 3 and balance 0. So now we're going to go over here, and I think I set this guy up too. Okay, so API tokens/get, type equals account, name equals singer shares. So I have 2 artists specifically in this one. These guys have created their initial share account, but they have not received their shares. So this guy over here, he was the token administrator, is going to go and he's going to debit to these guys.
Hold on, just one moment before you move on, Colin. I just wanted to clarify something, that the window you're in now, where you've created those 100 shares, essentially, called Greatest Hits Shares, right? You could have, I don't know whether you did or not, you could have created that token by tokenizing an asset, and the asset being the song Greatest Hits.
I haven't tokenized the asset yet. I'm doing.
But you could have done that. You can create a token in that way, and so the link to it. I just wanted to make that point, that would have been a step prior to this. That you create your asset called.
Actually, yeah. That generally we haven't decided the exact sequence. That's really going to be up to the application developer. I figured in this one I'd do a basic setup with the accounts of the currency itself, and then the tokens, and show the distribution of the shares.
Yep.
So that you can see this is the utility token. So token identifier is the utility that represents your shares in this. And then I'm going to create the asset over here. And then I'm going to call the tokenize command, actually tokenizing that asset and showing that this now gives these people with these tokens ownership of that specific metadata. And then I'm going to show this user over here purchasing and sending that to the asset so that you can see the split revenue and the notifications happen. So let's see, amount equals 50, session equals 10 equals 1, 2, 3, 4.
Drummers don't get 50. Surely the singer gets like 75 and the drummer gets 25, right?
I figured I'd make it fair, at least in this example. Okay, so API account/notifications, username equals drummer. So this is our drummer guy over here. Now he's going to see, all right, I have a debit to me of 50. So this guy right here is going to have to claim it. So he's going to go Nexus API, tokens / credit. Then I'm going to use the TXID of this as my claim to claim my tokens. And I'm going to say name2 equals drummer shares. Amount equals the amount here, 50 session. And then I'm going to have to go grab my session identifier right here. And then pin equals 1, 2, 3, 4. So I have just claimed this. Now,
sorry, I just want to kind of jump in as a user here just to understand what's happening. So the notifications that you've just listed, a notification is to notify you that you have been sent something, a transaction has come to you, and you then need to action that by claiming that transaction and putting the tokens into whatever account you want. So you can say, yes, I've been sent something and I want to put 50 of them into my savings account. Can you also, and I believe you can, say, well, I've been sent 50 because it's in my notifications queue. I want to put 25 into my savings account and 25 into my current account.
As the way it stands right now, you could set up a utility token to do that for yourself. But right now, the actual addressee is to an account. So I can add some extra functionality in there where this address is your Genesis, which is something I've been planning on doing anyway. And when it's addressed to your Genesis, that means that you're able to claim any certain amount from that. It's obviously going to have to keep a state of how much of it. So right now, it's a 1-for-1.
Yep. Okay.
The only time you have a many-to-one is what I'm going to show here. And you have a state. So if you have something where you have a revenue that comes in, let's say your paycheck, you can actually just use this same type of token system where you create your own utility token and you have a couple sig chains that manage different accounts. And one of them could split 10% automatically into that savings account and then another percent directly into your own account. Or then you could even have 5 tokens that you give to your son for allowance or something like that. There's a lot of things you can do with it, especially this is useful for more than just being, let's say, a musician. If you're running a company, you can do the same type of thing where these tokens represent how much of the budget allocated goes to each department or anything like that. Or these tokens can represent dividends or shares of a company where this metadata could be more than just a song. It could be a company's title or incorporation or whatever you want to call it. And these tokens that you own, which are also transferable, which means you can trade them on an exchange, will basically represent the revenue or the dividends, which I know there's an extreme amount of admin overhead as far as managing dividend payments and payouts to a lot of people. So this essentially automates the entire process for you. And it's not just for music that it's possible with. So I wanted to make that really clear. And this shows taking tokens from speculative instruments that store state of a value to being utility tokens that actually represent the value of some sort of revenue source, which any of this tokenized asset we do can be any type of asset. It can even represent joint ownership of a car or anything else. So I'm going to continue on. Is there any questions before I continue? Can you check that, Paul? Because I cannot check the chat box.
No, it's fine so far.
Or if you ever have any questions too, feel free to unmute your microphone and speak up. There's no reason to be shy. These meetings are meant to be interactive and open for people to kind of have a better idea of everything that we're working on.
Yeah, I'm going to keep asking questions, just the questions that people might ask, even if I know the answer to it, just to make sure it's a complete demo.
So I'm going to do another debit, name2. This time I'm going to give Singer shares an amount of 50. Then I'm going to just copy these from here since it is a little quicker. Now I am actually sending a debit to this guy. So now you see the block came through. This is private mode, so you see. So this is simulating a private network. I did this now because it's a lot quicker. We don't have to wait for blocks on the testnet and everything like that. But as you can see, this is generating blocks and they're clearing in their certain amount of time. Let's see. The reason this number is high right here too is for Argon 2, 1.951 or 1,951 milliseconds. Every Argon 2 hash takes an incredible amount of time to generate. And that's for the security of your SIG chain, just for clarity. Let's see. Let me grab this again then. All right. So we're going to go back to here. Okay. So now over here, we can do the same thing. Account / notifications. And we say username equals singer. Oops, I had a typo. My apologies. Now this is going to see that I have a debit here for this account that I can credit. So I'm going to do that just now. So we're going to pull the transaction identifier here, and that just is showing the link specifically to this transaction. And then we're going to say name2 equals singer shares, amount equals 50, and let me see if I can pull my pin and my session from here. Okay. All right, so now I get another corresponding transaction identifier so that when I go now and I want to check my account, Singer shares, I now have 50 shares and this guy now has 50 shares. So this represents a 50-50 split because as you see, the max supply over here is 100. So 50% and 50%. So now we're going to set this up. Actually, I'm going to create the asset first. So we're going to go over here and say API asset / create. We're going to say the name is greatest hits. And let me see, data would be album data. So I'm just using this as some basic values, but as object registries, you'll see it will not be a data field, but you'll be able to actually define each field, such as album name, release date, artist, genre, things such as that. So we're going to create this asset. Okay, now here's our asset address. Now that is resolved from the name for privacy's sake. So essentially the network itself only sees this address, but they if you know the name, you're able to access it, such as API name equals greatest hits. As you're going to see, this shows the album metadata as part of this schema. Now, the owner itself is the person that created this, but what's going to be really cool here is we're going to go API asset / tokenize. And let's see, let me double check this command. We have token name and asset name. All right. So token name is going to be greatest, right? Hits shares. Asset name is going to be greatest hits. Oops. And now I have to paste my session and my pin. There we go. So now what we do over here is when we go to notifications, is keeping track of these foreign indexes, which see, since they have the state of these tokens here, right, in their account, now they see a transfer to them, but it's an indirect transfer. It's not directly to their SIG chain or their Genesis. It's actually to this token account right here. So the same thing over here. He's going to see a similar transfer coming in. And this is showing that this is the actual name of the token. Let's see. Let me pull it up right here. Type token identifier. As you see right here, 82045 and 82045. So what's really happening under the hood here is this asset is now owned by this token, which since these have correlated foreign indexes to it, the transfers show up as something correlating to them because they hold the state of these tokens. So now we have a song that has shares owned by each of these individual parties. So what we're going to do here, we are going to create a currency account, because what these guys need to have is accounts to receive the Nexus or whatever native token that this guy has for identifier 1. So it's going to be a type account, identifier equals 1, name equals drummer currency. And then we're going to want to pull the pin and the session from here. So what this guy is setting up now is he has an account that is set up. So now he can receive currency of this identifier here, right? So I'm using identifier.
Sorry, and just to be clear to people, if this was identifier 0 instead of 1, it would be Nexus, and they would be able to receive Nexus coins. And more than that, the step that you just did then to create an account for identifier 1, for the Nexus coin, which is identifier 0, we will create a default account called default for you as well. I think we're probably going to create a staking one as well. We've just been talking about that on our previous call, but we are going to create that default account for Nexus. So if this was a test where you were transferring or using the currency identifier 0, that account or an account would already exist for you, right?
Yep. So the default account will be named default, your username : default. So that'll be your default account, and then username : trust for your trust account. So this setup isn't going to be necessary on your Genesis. It's actually going to create those accounts automatically for you, so that you can start receiving this. We're using token identifier 1 to show you that you can actually use any identifier as long as the receivers have the actual account that is the identifier of what this buyer is using. You can use any currency or any one of these tokens. So I think that allows a lot of flexibility. As long as these identifiers match up with one another, then the transaction is allowed to be fulfilled. Okay, so now we're going to do the fun part. So we get this register here. Looks like we have a comment, a Paul, or a question. If you want to grab that, Paul.
Yeah,
I think I saw that.
If I want to receive any token currency, I need to set them up, or am I able to receive it anyway?
You need to set up an account. Yeah, you can answer that.
Yeah, I was just going to say, you need to have an account for it. So the transactions still come into you, and you still see them in your notifications queue, but you still need to claim them. So this is something that's quite different from legacy, where you have this UTXO model where you have an address and the transactions just go straight to them. When you have a transaction with Tritium and with SigChains, the transaction comes to your SigChain, and then you need to claim it. You need to put that into an account.
And that's to prevent people from being able to lose funds. So since you have to accept it, the transaction itself will time out after a period of time, which means it'll return back to the sender if somebody doesn't accept it within a week or a month or whatever that timestamp is. So that way, when you send to an address, you can be rest assured that if it doesn't get there safely, if it was sent an error to an incorrect name or an incorrect account, then that will actually be returned back to you as the sender. So this will be impossible to burn coins, which I think is really important for user friendliness. All right.
On
so
the
right
subject,
here,
sorry, go on. I was just going to mention the event processor as a follow-on from that for user friendliness. This concept of having to claim transactions that are coming in, we realized that that's not particularly user friendly for people who are used to coins just showing up in their accounts when people send them to them. So we're having this event processor which kind of runs in the background and looks at your notifications queue, and you can configure that to automatically claim transactions and put them into the account that you've configured. So a really good example of that would be that you configure any Nexus that come in to go into your default account, so that you don't have to go to your notifications queue and claim and monitor it and claim it. If you're running our UI, for example, then you can configure it to automatically look at your notifications and automatically claim your Nexus transactions or whatever token it is and put them into the account that you've chosen.
Exactly. Okay, so right here, I'm going to transfer 1,000 of, let's call this token. Let's just pretend this token's Nexus just for the sake of it. This is our shares token, and this is our Nexus token. So this guy right here is going to debit as a buyer because he's paying for this song. Now, what he's going to basically be doing is that's going to be creating a commitment, which then both of these guys are going to be able to see in their notifications queue now. Another debit come in their name. Let's see. So actually, that one didn't work correctly. Verify the asset name. Use the wrong address. Sorry, guys. All right. So, wait, no, this is. Yep, I used the wrong identifier. So it needs to be to this specific asset here. Let's see. All right. Now we're going to see this go and show up in your notifications queue. So now after this block clears, this shows that there's a state of this debit here. So what I basically did here is I actually debited, the first mistake I made, sorry, was I actually debited to the token account itself, which was incorrect. What I needed to do is actually debit to the actual asset itself. So now this asset holds this state. So let's check. And now it shows that there is 500 Nexus here. Specifically that's sitting for me to claim because the transaction itself was for 1,000 Nexus, but since I have 50 of these tokens out of 100 total, which I believe this number is right here, that means I have 50% of the actual value. So now this is where we get the cool part. So we go tokens/credit, and now we do TXID. We have the hash itself right here. And then we're going to go and we're going to say name proof. And this is going to be drummer shares. And we're going to say name 2. And this will be drummer currency. Amount equals 500. And then we're going to want to copy the pin, everything over right here. All right. I'm going to omit this space. So what I'm doing here is I'm actually claiming some of this. So I'm crediting, but as you see, there's something different. It's called the proof, right? So what this proof means is I'm actually using my account name, drummer shares, excuse me, is the temporal proof that represents my balance or state. So the way this works is it's got some different indexes. Since this asset, is owned by the token, then the token's owner is actually red, and then that value of the max supply is compared to your value that you include in your proof. And that's how you prove, being the owner of this specific account, that you can claim those shares. So if I try to do it again, it's going to fail because the temporal proof has already been spent, right? This is a nice little thing too. Paul added in, we have a little bit more visibility into the actual errors that are spawned from the operations layer. So this is only allows you to claim this specific proof once. And now you see he has now a balance of 500, is half of that transfer here. Now this guy over here is going to do the same thing, accounts notifications, and he's going to see he has a debit in for 500 Nexus. So he's going to run a similar tokens get, tokens credit, TXID, and I'm going to include the same transaction here. And then I shall do name proof equals singer shares name 2 equals Singer currency. Amount equals 500, since this is the amount here. And then I shall copy my session identifier and my PIN number. And now I was able to execute so that when I run and do tokens get and I check my Singer currency account, I now have 500 tokens. And as well, if I try to double spend, I have a temporal proof that has already been spent, so I'm not able to claim that twice. So now what, in a higher level, what essentially happened here is this buyer was able to take some of his currency that he has and transfer it to an asset that was tokenized, which means it was governed by the ownership of the balance of the temporal proof here and here, or that account. And that balance of that account was able to be used to prove that you have rights to a certain percentage of a debit. Now, some of the other use cases that we're having and we're developing for these specific tokens is voting tokens, where the token itself actually represents shares in a vote. And that can help start to be governed by validation scripts, where the validation scripts themselves are actually executed and verified off of these voting layers. That's part of what we're working on developing in for the ambassador keys and so on and so forth, so that it becomes a more democratic process where these tokens right now represent your ability to receive partial revenue, but what they're going to mean in the future is your rights in a DAO. And the DAOs themselves are going to be able to be self-regulating based on the amount of tokens you have. And since these tokens are transferable like any other token or exchangeable on the decentralized exchange, then you're going to be able to essentially buy and sell them at will, which allows you to buy and sell rights to the DAO and then have all of this enforced directly onto the network and create kind of, I guess, better community governance models, which I think there's a lot lacking in the decentralized world, as we were talking earlier about having, let's say, the issue with GitHub. I mean, that's one big governance issue, which has spawned 2 Bitcoins because it's been such a big, large issue. And so we focus on that as, I guess, a really prime thing. I think decentralized governance is really important for people to implement and use, especially being that I see a lot of these decentralized systems degrade back into centralized systems because there's lack of social architecture. So we're hoping to be able to take a good stab at that. And with the initial distribution that we have right now, the embassies, and also getting more community involvement, we're hoping to see a lot of that kind of come to light. So that concludes our demonstration. I guess we shall upload this video to YouTube as usual. And I guess before we close, we shall answer some final questions any of you have regarding this specific demonstration. And we will do our best to continue with demonstrations as they evolve. Now that validation scripts are done, it's going to be quite a lot easier to show you decentralized exchange. So no promises that that'll be next week, but we'd like to show you more functionality and especially user interface functionality. So be expecting more of these demonstrations and continued transparency from the development team. And we appreciate everybody's support. Are there any final questions before we conclude?
Nothing that I can see.
I think we got another one in here. Thank you for Nino.
You hear me?
Yeah.
Yeah, hey, I think you had mentioned earlier in the call showing some of the performance you were getting on the validation scripts. Do you have that up there that you can run it?
Yeah, I actually do. Let's see. Good call. All right, let's go back into this. Share screen. So this is on a slower laptop. Let's see. Actually, I could probably pull it over here. I think this is running my latest Viz branch. Okay. Build benchmarks. actually make sure this is up to date. Yeah. Sorry, I have to recompile this. All right. Haven't touched this one for a couple days. All right. Still compiling. Let me see. I guess at this moment, we're waiting for that. God. So if anybody wants to verify these tests for themselves, you're perfectly able to look specifically in here. Here's some of the unit tests. This is testing some of the virtual machine. See, this is where you get some of the cool object register stuff, where actually you can read a register by name or hash directly into it, or I can actually go and read the value of a specific object register. In this specific case, you can see I'm reading the value test, or reading the value balance, or reading the value identifier, and then asserting that that is equal to true. So I figure while we're waiting for that to continue compiling, this is kind of some of that code and how it all works. So this is what static analysis or static testing means, is that it's all written here, and then every one of these things are required to actually validate to true. So now we're just compiling the rest of the legacy stuff, which is quite a bit, but we got through most of it now. Let's see. All right. So we'll just run one simple test here. Everything should be good. I can test this for a couple of days, so fingers crossed everything works. So we'll just run Nexus here with benchmarks. All right, so this one right here is running on my laptop, which this laptop's quite slow. Oh, no wonder it was taking such a long time. So this one right here is 33 million operations per second on an addition. Multiplication is 35 million. Exponentiation is 22 million. Subtraction is 36 million. Increments are 38 million. Decrements are 38 million. Division is 35 million. Modulus is 35 million. This computer is generally on an order of magnitude about half as fast as my desktop right over there. So this is kind of your consumer grade Apple laptop. So this is kind of like average hardware. So this right here being about 35 million operations per second. What we do 1 billion divided by 35 million. I think the average nanoseconds. 2, 3, 2, 3. By 35. Okay, so that's about 28 nanoseconds per instruction on this specifically. In other words, that's really, 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 really fast. The best benchmarks, I haven't run Ethereum virtual machine benchmarks locally because I haven't really cared to compile it. But from benchmarks, I saw other people claiming they were marking around 1 million nanoseconds per instruction. So this is really, really, really fast. Then we have object register parsing. So these are our object register benchmarks. So this is our validation script running on the virtual machine itself. Anybody that wants to test this code, you can pull my viz branch and build with benchmarks equals 1, as you saw for me. And that's going to switch it to this special main method here that runs all these benchmarks themselves. So it parses about 5 million register values per second. It writes about 10 million bytes per second, about 8.1 million 64-bit unsigned integers, about 9 million strings per second, and about 10 million vectors per second. And then we have reading of about 11 million bytes per second, 10 million 64-bit unsigned integers, 10 million strings, and 10 million vectors. And then signature chain generation, this is a benchmark just to see exactly how slow it really is to generate. So to generate just my Genesis ID took me 891 milliseconds. That's about 1 second. And then to generate one key right here, which in order to create a transaction, you actually have to generate 2 keys. You have to generate the first key that is signing the transaction and then a new key for your next hash. So to generate a key, it takes 947 milliseconds, which what that basically means is that if you if somebody else is trying to brute force attack your account, this is a hardware limitation where they can only guess, in this case on this laptop, about 1 password attempt per second, which is very, 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 very slow. So yes, that shows some of the benchmarks. I'm obviously adding more and more benchmarks in here. So if anybody of you want to verify these test results for yourself, you're welcome to. They're located in the Viz branch, and you compile with benchmarks equals 1, and it'll run this little program that you see right now.
That signature chain benchmark you just run, where it took a second to generate your Genesis, that's by design. That's because it needs to be slow because it's using Argon 2, right?
Yeah, and if it were fast, then that means somebody with a GPU farm would be able to crack your password that much faster, right?
Yep. So, and the same with the 1 second to create a transaction. That is going to allow us to remove the limit of 1 transaction per block that we currently have, because people will be, which we have to stop spam transactions. People will be limited anyway by hardware, right? They just won't physically be able to generate more than 1 a second-ish.
Yep. So it's a security parameter, but it also helps for reducing network load. But it's not like IOTA, where IOTA actually requires you to do proof of work for your transaction to get confirmed. You actually have to do a bit of proof of work to even generate your own transaction. And that's by design so that anybody else that wants to try to attack your SIG chain would have to do proof of work, an incredible amount of proof of work to try to attack it.
Did we decide that people would be able to change the parameters to Argon 2 in order to...
Yeah, you can change them at will. You have to remember your parameters. So if you choose, like, I think we're using a computational intensity of about 14 right now. You can make that 100 if you want. But if you change that number, your hash is going to be different. So you're going to need to remember that number if you do change it. But it will be user configurable for people that are extra paranoid and want to make sure it's even more ridiculously difficult to try to hack into somebody's SIG chain. It would, you could set it to 5 seconds or 10 seconds or whatever you really want.
So I was thinking the other way. If we had
easier, yeah.
If we had an enterprise application where they had a use case where they needed to generate a lot of transactions, they needed it sub 1 second or even.
Yeah. Well, the private blockchain side of things is a lot different. This one being public, every SIG chain is public, so people are going to first have to try to brute force your Genesis, and then they'll try to brute force your password and everything. So, it can be configured to be really quick if you'd like as well, just by choosing memory allocation and anything like that. So. Yeah, but generally the transactions themselves can be batched with multiple operation scripts per. So that's kind of one thing that I guess can help with the volume needs for specific enterprises.
So in layman's terms, you can create one transaction that does multiple things.
You can make one transaction that does 100 things if you want. Yeah, in layman's terms.
Okay,
All
cool.
right. Cool. Well, I guess if there's no more questions, that concludes the Zoom for this week. And after the Zoom, I shall download it off the cloud and upload it onto YouTube for everybody to watch that did not catch this specific one. So if there's no more questions, we shall conclude. Any last questions? Good.
Nope.
All right. Well, thank you, everybody. We appreciate you joining us for this week's Zoom, and we shall see you next Wednesday at 6 p.m. is what we have changed them to, 6 p.m. Pacific Standard Time. We're going to just lock it at Pacific Standard Time because Arizona changes a little bit here and there and everything too. So 6 o'clock Pacific Standard Time next Wednesday. We shall see you. All right. Thank you, everybody.